to the attendance in the chat. I will later on again just add it into the chat, and at the end of the session I will also add the evaluation form for you guys. Also, anyone joining for the first time today, I just want to quickly check where is the link to our WhatsApp group, so that if you guys want to join the WhatsApp group, you can do that. So let me just add that for you. Cool. So link to attendance in the chat, also a link to the WhatsApp group. If you can't get access to the WhatsApp group, you can always send a WhatsApp to me as well on 083-790-8387. And then just again, for the guys maybe still struggling to get access to the Western Cape portal, please send an email to ctntat@unisa.ac.za. I will add that email address into the chat as well, so that you have that. So please, if you're struggling to get access to Western Cape portal, please do send them an email from your My Life account, that they can see your student number included, and they will open it up for you. Okay, so last week we looked at the first chapter, which were on numbers and variables, and tonight's session we'll see how far we can go, but we will definitely cover everything in chapter 2. So we will look at operations. We will look at powers. We look at roots, and also have roots and order. So we will look at that. So the guys that might have done QMI, there's some of this that was covered in that subject as well. So it might be repetition for certain people that have had for other subject as well. Okay, so we'll go through that. We'll go through some exercises. We'll definitely look at examples so that you guys can practice it and look at it as well. Okay, and then probably next week, when we look at the next session, we will probably look at those two as one session. So, but we'll see how far we get tonight, and then we'll plan accordingly for next week. But that might be one session when we look at it next week. Okay, so what we're basically looking at today is looking at basic operations. So nearly a few things that we need to be able to do after the session, and I will also again put the recording and the presentation onto WhatsApp as well. So I'll do that after the session again tonight, like I did last week. Okay, so the first thing that we will need to look at is that we're going to look at basic operations. We need to perform it. and we will look at when numbers and variables, then how to use basic powers and roots in calculations, and then the last part of this chapter that we will need to look at is how to perform multiple operations in the correct order. So sometimes they refer it as BODMAS, other times they refer it as other short names, but we will look at that and see what is important for you guys to look at. Oh, I see this chat. My computer is a bit slow to switch over, so I will see what is in the chat now. I don't know why it is actually doing that. Hey, on my side, the screen has frozen. Let me just quickly, can you guys see the screen at the moment?
Yes, I can see your screen, sir.
Okay, perfect. Okay, thank you. It was just frozen a bit. So yes, if you want to join the
But
WhatsApp group, please, there is a link. I'll share the link later on again as well to join the WhatsApp group. Okay, so basically basic operations. So the first thing around the basic operations is that we're going to look at, and I should have written the other way around. So multiplication, division, addition, subtraction. We're going to look at it where it is numbers on its own, but most likely in the exam, it will be the mix of numbers and variables. So that will definitely be a big focus in your assignment, but also in the exam. Then what I've added for you is things that sometimes they phrase it in different ways. So I just added how they can phrase it, because sometimes they say sum the following or add them all together. So I just put in also here some of the things that might be in the question if they don't use the words like addition or subtraction or multiplication or division. Again, there's always in a question a area where they nearly want to see if you can make a mistake, if there's things that they can catch you out. So that's why I nearly wanted to just give you all the other words that they might use with the, instead of just saying addition or subtraction, so that you can look at the different wordings in some of the questions. Okay, so that is the basic operations of the numbers. Then what they will bring into the numbers is variables. It might be any A, B, C. So they usually love to include A, B, C or X, Y, Z. So they would nearly give you the variables that they start to include. With that, there's then certain things. So the number in front of a variable is called a coefficient. That coefficient does not need to be a whole number. It can also be something like 4/3. So the coefficient does not need to be a whole number. And then most likely in that expression, you will also get a constant. Again, that constant does not need to be a whole number. It can be a fraction as well. And what normally split it into terms is an operation. So, and that operation can be then any one of these basic operations. Okay, so that is how we will look at it from a variable's point of view, is nearly with a number that will be seen as a coefficient, there will be a variable, and then in the next term, there might be only a constant, there might be two constants, so x plus y plus 3 can also be an expression with two variables and one constant. Okay, so the idea just behind a variable is that it takes the place of a number. Then what the next step is nearly, so we've now looked at numbers, we looked at the introduction of a variable, and then the third thing that we bring into play nearly is powers. So what we will see in powers is that you will have a base. So that base again is a whole number, and we will say that base to the power of. So to the power of 3, to the power of 2, 5 to the power of 5, where that to the power of is basically called an exponent. So again, a lot of nearly theory in this. They normally don't ask theory. Maybe one question or something like that will most likely be more practical, because theory is something that you might just get out of the book as well, but they might include one question to say, they give you something like this, and they say, well, that number 3 is a power, it's an exponent, it is a variable, it is a constant, it's an operation, it's a coefficient. They might do something like that, where they look at one of the expressions and ask you nearly something like that, that might be seen as a definition type of question. But else it will be questions like simplify the next equation, or simplify the expression, or things like that. Then another component in this study unit is exponents. And what I did here is nearly to look at all the different rules. So in your study guide, there is, I think, 10 to 15 pages of examples of exponents and all the rules and those kind of things. So basically this is a summary of all of them. And again, most likely they're not going to ask you what is a product rule or a quotient rule or power of power rule. They would give you something like this that is in this component, and they will ask you to simplify it. So they will not really focus on what the different laws are. They would rather look at it from, give you an example or give you an equation, and they will ask you to simplify it. We will go through a lot of them after we've dealt with all of these components. So don't worry, we will definitely look in the next 10 to 15 minutes at all the practice around that. But I think one of the more important ones to know is this a to the power of 0 is equal to 1. So that means that 100 to the power of to the power of 0 is also 1. 5 to the power of 0 is also 1. So anything to the power of 0 is equal to 1. And what might happen in one of your questions that you get is you might get a long row of things, and somewhere in the middle there is a x to a power of 0, and it might be that you handle it wrong, and then the answer might be wrong. So very important, anything to the power of 0 is equal to 1. Okay, so that is for me one of the more important ones, because it is very frequently used in a lot of the expressions. Okay, then, so we've done expressions, then we look at roots, and then we'll also look at square roots, or again, different components of that. So if you look at here, everything is to the power of 2, so we call it square root, but you can also get something to the power or to the cubic root, and then it becomes, you get different other ones, but what it's called, don't have a faintest idea, but you can nearly have anything as the power that you could have had 5 to the power of 7. You can actually have also a root that is something 7. Again, what it's called, one can nearly Google that, but it's more about the principle than nearly what is around the root. So the most things that they normally will ask you is the square root, which is just this. It might be that they add the 2, so this symbol and this is exactly the same. Okay, so to put a 2 there or not to put it there, it is exactly the same. So some books might add the 2, some might not have a 2, but this is exactly the same. So if I had the square root of 4, or if I had written it as this square root, it will basically be, your final answer will be 2, because it will be 2 to the power of 2 is 4. So those 2 will cancel out, so that you sit with 2 in the end. Okay, so most likely is that you get the square root, but if you get others, it will always be so that you can work it out. So this will not be one. So if they give you something different, it says, let's say it is free, it will be something that you can nearly get the root or nearly the exponent of. So it might be something like 27, where 27 is 3 to the power of 3. So 3 times 3 is 9, times 3 is 27. So it might have been that they say and they ask you to work that out. So then again, one could see that you can cancel those out to get to 3. So they will not ask you to work out what that is, because it's really it's not making sense. It will be 3 comma something. That's not what they want to do, because you can't really simplify that unless you're using a calculator, but that is not really what they want you to work out with roots. So they will not ask you something like that, but they can nearly have whatever the answer of 2 to the power of 3 is, or 5 to the power of 3. So let's quickly check what is 5 to the power of 3. Okay, so they could have had something like that. Which would have been 5 to the power of 3. So then again, the 3's will cancel out. So they won't give you something that is not really able to take the roots of it. So again, they won't ask you something like the cubic root of 29, because then you, in any case, going to write with or work it out with your calculator. So it's not going to make sense for them to ask it. And then the last section that should have been actually up front is this for orders of operation. So sometimes in some books, and I think on some of it, the Telegram groups, there was also a lot of conversation about what is it called. So in certain instances, it's called BODMAS, where it's always for brackets first, then orders. So if there's any exponents or square roots or anything that is in there, it's part of the orders. Then division or multiplication, then addition or subtraction. So some call it BODMAS, some call it PEMDAS. So again, just it's just a abbreviation to nearly get the order of things. So for me, it's easier to always reference it as BODMAS. Again, like I previously said, English is not my first language, so for me to even understand first what that word means is where brackets, it's very easy. I know what brackets is. I don't always know what parenthesis is. So it's nearly, sure, I would nearly always try to nearly remember what BODMAS is, but I know some of the books also mention it as PEMDAS. There's even other words that they also use. So all that it comes down to is when you get a question to simplify or to work out, just remember to follow the principles of this, so that first do brackets, then if there's any operations of like exponents or roots or anything like that, that's the next one that you do. Then look at division, then look at multiplication, then addition, and then subtraction. In your answer set, you will probably get that if you swap some of this around, there will be an answer for you. So that is why this process is so important, because it will definitely be if you did addition before multiplication, there's a very good likelihood that one of your answers will be in that answer set. So just nearly look at this and again choose the one that's the easiest for you to remember. If you like the PEMDAS, use that. If you like BODMAS, use that, but use the one that you are comfortable in remembering, because that is nearly the one that will assist you in the assignments and in the exam. I just want to repost the letter of attendance. So if you guys can just, if you haven't completed the form for letter of attendance, please do that. And then later on, I will also just share the evaluation form as well. So I'm actually going to put it in there now so that I can just later on copy it out. So the first one is the attendance form, and the second one is evaluation form. So we'll recopy both of them later again. Just also for the guys joining in between, the session is recorded and will be shared in the WhatsApp group, as well as the presentation will also be shared. Okay, so let's look at questions. So we'll go through all of them. So first, if you just want to take a stab at it and see, you can see the first one is just looking at the same variable, and then there's operations linked to it. The second one, there's multiple variables and operations linked to it. And the third one, also multiple variables and operations linked to it. So take a minute, just see if you, I am going to go through it in any case now, but if you want to maybe just try one of two of them, and then we'll definitely start discussing it. Okay, so the first one. So if we look at the first one, we only have A's, so only got one variable that we will work with. So in the end, my final answer will be something A. Okay, so let's look at that. 15 minus 6 is 9. 9a minus 7a perfect is 2a. Okay. So great. So again, identify nearly the variables that you're going to work with. And then it's a bit simpler to solve the numbers if you know that your final answer will only contain the A. Question 2, bit different because there's one variable there in A, and then there is 2 variables in B. So what I would normally do is I would say, okay, well, A and B must be in my final answer. So there's only the 3A. Then on the B side, it is 23 plus 4, which is 27. And there's no mistake in writing it as 27b plus 3a. Okay, so exactly the same. It might be that in the answers, they might rather put this one as the answer, but they will not put both because it is exactly the same. So just check nearly if when you look at it that you look at it and check which one is in the answer set. Okay, so important more to look at the answer set, but both of these are exactly the same. Okay, so okay, next one. So the third one, okay, so let's see, there's a x, there's a x. Those two will go together. There's a y, and there's a y. So it normally is best to have it in the alphabetical order, but again, it is multiple choice. So it might be that they will, in your answer set, nearly force you to look at it as if it is in alphabetical order. So that is most likely how it will be, is in alphabetical order, but it is not wrong to put it the other way around. But Zenani, what they will most likely will do in your answers is they will most likely have that 3a plus 27b as an option and not the 27b plus 3a, but it is exactly the same. So it might be, what we will normally do is we will put it in alphabetical order. That is just how one is nearly learned how to do it, but it's not wrong to do it the other way. So again, when we look at the third one, it will normally, we will look at the x first and then put the y. So even if they had it as minus 7y plus 3x and then the rest, we will normally put it in alphabetical order, that we will have the x and the y. Okay, and in this instance, it was 3x minus 24x, so it is minus 21x, like you guys said, and then it's minus 7y plus 8y, so it is plus 1y. Again, plus 1y can also be shown as just plus y. It is inferred that if there's not a number in front of the variable, it is actually just the number 1. Okay, so again, most likely they will show this answer, as most of you did in the chat, as minus 21x plus y. Okay. Okay, so that is just looking at simplification of the expressions. Then following up on that, now we have multiplication. So multiplication, again, you can, if everything is multiplication, it doesn't matter which one you multiply first. But again, we will probably want the final answer to be in alphabetical order. Okay, so what I would again normally do is look at the variables first. So I will see there's 1a times another a, so that will be a to the power of 2. Then there's 1b, there's 1c, so it will be and c. And then I will look at the numbers to say, and normally then I will get my calculator. 13 times 4 times 3 times 2, I get 312. Okay, so the important thing here is when you look at 13a times 2a, remember it is a times a, so it is a1 times a1. If we go back to where is that rule, it was a1 times a1, so it's a1 plus 1, so 1 plus 1 is a to the power of 2, and not 2a. So just be careful not to write it as 2a, because then this answer will also go probably to 624 ABC, which is not correct. So again, remember when it is a times a, they explicitly don't include the 1, so don't make it confuse you that there's nothing. So in actual fact, again, like if it was y in front of it, there's always a 1. It's the same. There's always an exponent of 1. They just don't show it. So when we look at the second one, again, here we have a x times a x. So there will be a x to the power of 2 in it, and there's a y times a y. So there will be a y to the power of 2 in it. And then the other numbers, I would again use the calculator. I am not going to try that, try to do that out of my head. So 4 times 4 times 2 times 6 is 192. Okay, so again, just nearly remembering here, it was exactly the same rule. The x1 times the x1 gives you x to the power of 2. And the same with the y's, the y to the power of 1 times the y to the power of 1 would give you y to the power of 2. So again, they didn't show it here. They don't need to. It is inferred that if there's nothing, there is actually a 1. Weird, but that is how it is. Again, it's not again to the power of 0, because a to the power of 0 is 1. So remember, again, if there's nothing, it does not mean it's to a power of 0, because anything to the power of 0 is equal to 1. So that will again change the answer. Okay, so this was only looking now at multiplication. So the first one we looked at some subtraction, some was adding. Then we looked at subtraction and adding together. Went into multiplication. So now here we have a few different ones. So now we introduce more of the exponents. We introduce a division as well. We introduce exponents and different variables. So we mix it up a bit. So let me just quickly see if I can copy these rules for you into that, because that might be nice just to again have it at hand, so that we don't need to look between the different slides every time. Okay, so in this question, we will now see that there is, so there's, everything is multiplication, so then it doesn't matter what order we go through, it will be the same. And then we'll see, okay, there's A's and there's B's. So one will be A, one will be B. Okay, and then we can look at it with this way. So A to the power of 3 times A minus 1. So A to the power of 3 times A to the power of minus 1. So that will just be 3 minus 1. And then the B will be 2 plus 4. Oh, is it for everyone that can't see the screen anymore?
I can still see.
Okay, cool. Thanks. Okay, so perfect. Okay, so now to simplify that, it is 3 minus 1 is 8 to the power of 2, and B is 2 plus 4 is 6. Okay, what we will also look at is now the difference between question 1 and 3, because in here we set the A minus 1, but nearly look at what we are doing here, so that we can get to the second one now. So that is the same. To say, well, P3 divided by P2. Okay, so if you look at that, so what that will be is P3 minus 2, which will be just P1 or P. Perfect. Okay, so they could have written it as that. They could have had it as okay. So all of these three is looking at the same way of writing that formula. And they can ask any one of those three for you in assignment or in the exam to simplify. So just important nearly to always have that view, especially for division, that they can ask it a few ways. Okay, the other one, again, multi-variables, so there's x's, so we know that there will be a x, then there is y, so we know there will be y's, so it will be 4 plus 3. Okay, so again, plus 1, so remember that there's always a hidden 1 if there's nothing. And for y's is y4, 5, 6, 7. Okay, so the y's will be y7 because it will be 4 plus 1 plus 2. Okay, so again, when you look at that, they can again change that a bit up. What they will do again in your answer set, and I think that again is important, is most likely they will have it in alphabetical order, your answers. So if again y4 was the first one, they will normally have it in alphabetical order, your answers. So again, just make sure that when you look at your answer set, that if you had B6, A2, again, it is exactly the same. So if this was your final answer, just check if your answer set says B6, A2, or if it says A2, B6. Again, they won't have both as an option. They will only have one of the two as an option. And again, to the previous comment, normally it is in alphabetical order, that it's the A before the B, just so that you guys get used to it. Okay, then this should have been a bit to the front, so I'm moving it just there. So if you later go through it, it will be in order because they will normally start off with just the numbers, then they will add the variables. So sorry about that. But different in this one. Here they actually wanted to test the BODMAS principle more than the numbers principle. So here they wanted to test that you can do it in the order of operations. So let's look at the different ones. So here we have a subtraction and a plus. So it doesn't really matter if we say 13 minus 29. Ew. Let's quickly go back to this one. So if they said let's see, p to the power of 3 divided by p to the power of minus 2. Okay, that's an interesting one. Okay, so let's look at this. So p to the power of 3 minus 2. Okay, so then you will need to have that minus before you have the minus 2. And that will then be p3 minus times a minus is a plus 2, which will then give you p to the power of 5. Okay, so a very nice actually question to ask, because that might be likely that they can ask you something like that. So if they have it as p to the power of 3 divided by p minus 2. So just then remember that minus 2. Okay, because we need to say whatever it is minus that n, the n was minus 2, so it will become minus 2, which will become a positive 2. Okay, nice one, that, because that is very likely seeing some of the previous exam papers that they might ask you something like that. And again, I will share later on more exam papers and things like that with you on the WhatsApp group as well. Okay, so when we look at simplification of expressions of BODMAS, remember there's certain things that we said order is addition or subtraction. So you can say 13 minus 29, which is minus 16, plus 17, which is then 1. Or you can go and say, let's put all the positives together, which is 30. We can then subtract 29, and you will also get 1. So again, there is, with the simplification process, you can group things together that you first want to do if it is not in brackets or anything like that, so that you can do it that way. Okay, it's something different if there was a division. We will get to a question like that later on. Here, I will just run from the one side through to the other side. So I would just say, okay, 19 plus 23 is 42. 42 minus the 52 gives me minus 10. And then if you minus 7, 10 minus 10 minus 7 is minus 17. Okay, so you could have said, okay, let's put all the negatives together, which would have given you minus 59. You could have put all the positives together, which would have given you 42. So if you did that same calculation like that, again, you would have gotten minus 17. So if it is addition and subtraction, the only things in the same line, it really doesn't matter which one you do first. So for me, I normally like to work from left to right. But again, if you like to put all the negatives together, all the positives together, and then do the next step, also no issue. So again, nearly use what is the easiest for you to solve. Okay. Question 3 is an interesting one. So here they want us to do, we need to do the brackets first. So remember from BODMAS, brackets first and then only operations. So brackets first, so 3 plus 9, 3 plus 6 first, so that is 9 to the power of 2. And then the other bracket, 5 minus 2, which is 3 to the power of 3. Okay, so that is the process that we need to follow first. So that will be 9 times to the power of 2 is 81. And 3 to the power of 3 is 27. And that will be something like 54. Okay, here there's no shortcuts or other way to do it. Here basically you need to follow the process of work out what's in the bracket, then do the order of that, the second round. So you can't, and then only, so first is the bracket, then it was to the power of 2 or to the power of 3, and then only you do that after you've solved it, the minus with the 2 brackets. The same if it was a plus, the same if it was multiplication, the same if it was division. First the brackets, then the order, and then only you do the operation that is the thing in between those 2 terms. Okay, so very important that even if it was multiplication, do the brackets first, then the order, and then only the multiplication. Okay, so question 4, slightly different, but still important. We do brackets first. So 3 minus 6 is minus 3 to the power of 2 minus what's in brackets is 7. Okay, so some of you guys are now being caught up. Okay, so what is minus 3 to the power of 2? Okay, so also look at it. What is minus 3 times minus 3? Is positive 9. Okay, positive 9 minus 7 is equal to 2. Okay, so very important to remember, because to the power of 2, if it was to the power of 3, then it would have been minus 3 times minus 3 times minus 3 would have given you minus 27. So remember, if it's minus times minus is positive, minus times minus times minus, it becomes then again negative. So unfortunately, they would probably in your assignment and the exams, one of the options would have been minus 16. That is just how they will work. So that will definitely be, unfortunately, also one of the options. That is just again, unfortunately, how they will do it in the assignments and in the exams. So they will probably have that one as a +9, a -9, or what they could do is to say, well, if you set -3 times 2, you probably would have gotten -6, -6, -7. So one of the options might even be -13, because it might be that you do it that way wrong. So just be very careful with these options, because there will be nearly an option for anything that one might have done incorrectly. So even with the previous one, where it was the 9 to the power of 2, so they might even have that as a positive for an answer. So they might, one of the answers might even be 81 plus 27. So that you nearly might think, oh, but shucks, should I not have done something with that negative sign as well? So just be very careful when you look at the options, how some of them might seem that not confuse you, but you might look at the options and you might say, oh, but might it not be, or is it not one of the others? So let them not nearly put doubt in your mind with some of the weird options that they are giving you as some of your option sets as well. Okay, so that is nearly looking at some order. There was not multiplication in here yet, so it was only looking at, there was a subtraction, addition, brackets, and then if there was any order or exponents. So let's now look at a typical, so here the last two is typical questions that will be in your assignments or in the exams. So where they give you a few things and you nearly need to simplify it to get to the simplest option. Okay, so again, how I would like to show you this is, again, you guys might not in the assignments be pressured for time. I don't think it is time limited, but I might be wrong. But normally you've got in the assignments enough time to complete the assignment. It's more in the exams when they start putting more time pressures on you. So how I would do this as prep for the exam nearly is, I'll go through this and say, okay, I first want to see all the things that is only a constant. So I look at, okay, not, so there's one that's only a constant, not, there's two that's only a constant. So in my final answer set, I will have something that has a constant of 3. Okay, so that must be there. So if I look at my options, okay, so there's a 3, there's not a 3, so that is not an answer, there's a 3, and there's a 3. So we actually have eliminated one of the answer sets already, because it must have a +3. Okay, so then I would look at another the xy's and just focus on the xy's. So there's a xy, there's a xy to the power of 2, so we ignore that. There's a y to the power of 2, we ignore it. Again, x to the power of 2, ignore it. Okay, there's a yx, which is exactly the same as a xy. So in my answer set, there will be a 2xy. Okay, because the xy plus the yx will give me the 2xy. So let's look at options. So 2xy, yes, still there. X to the power of 2, y to the power of 2, not there, not there. Okay, so now we can see that in the second one, there is no xy. Cancel it out. So we can say that is not one of our options. Last one, yes, there is xy. So now, if you needed to guess, you're running out of time. At least we are guessing only between two of them. Okay, so let's look then at the next one. So there's a 3x to the power of 2. So all the x to the power of 2's. So there's that one, not that one. There's that one. So 3 plus 1 is 4. We've got x to the power of 2 with y. So 4x to the power of 2y. 4x to the power of 2y. So we're still happy with option 1 can be. Oh, here it's not 4, it is 6. Okay, so that is wrong. Okay, so with not even doing everything, option 1 is our answer. But let's just then, okay, so that one still needs to be added. The 2xy to the power of 2 plus. And there it was. So again, you now see that this wasn't arranged according to the normal way. So if they wanted to really arrange it according to how it should be, it would have been 4x to the power of 2y plus 2x y to the power of 2 plus the 2xy plus 3. So if I really wanted to do it in the mathematical order, that is how it should have been. So again, it's not always that your answer set is in the alphabetical order or the right mathematical order. So again, yes, we always say that is how we want the answer to be, but they also don't always put it in that order. So it's nearly for yourself to realize that we can mix it up a bit. Okay. So now we sit with the next one. So this is square root. So there is a 2. So what is happening inside is that we need to take the square root of that, and then it will be a 6 divided by 2. Let's just take that away. And b 36 divided by 2. Okay, cool. Thanks, guys, for the positive feedback as well. So this is how all our sessions will be. Is I really would go through it and explain how to, and also to look at shortcuts. Okay, so that is how we are. Yes, Ashley.
Sorry to interrupt you, but I think it's best that we go back to question 10 because I see someone in the chat is asking, how did you get to 4?
Oh, okay, cool. Let me quickly. Oh, I see there was option 4, and then they responded as it's option 2. So let's quickly. Where do we get the 4? Okay.
Yeah, so I think they're asking, where did you get 4x2y?
Okay, perfect. So let's quickly just look at that. So there's the 3x to the power of 2y. And there is the 1x to the power of 2y. So the 3 plus the 1 will give you the 4. Also, again, so now what is also important nearly is to see if you write something as xy, it's the same as yx. If you write something as x to the power of 2y, it's exactly the same as yx to the power of 2. Okay, so that is what is important nearly in all of these things. So that's why they specifically in question 10, what they did here to try and catch you out is they did the xy and the yx. They did the x to the power of 2, x to the power of 2, and the y's. And then they've thrown in this one where there is not a x to the power of 2. So that's why nearly they add this as an option if you made the mistake of thinking that, okay, we can add the 3 and the 2 and the 1 together because we've got something to the power of 2 and something to the power of 1. Okay, so that is why option 4 was included there, just to make you confused with what you do with the xy to the power of 2. Okay, so that, because it is not x to the power of 2, that stays on its own. You can't add it to something that does not look to it. So even if you swap it around, it still will be 2y to the power of 2x, which is not the same as that. Okay, so that is where they wanted to catch you out to see if you're going to say 3 plus 2 plus 1. Okay, cool. On question 11, so what I would have done again first is nearly get the square root of 36. So square root of 36 is 6. Okay, so that tells me option 3 is a no-go because it's 18. Option 4 is a no-go because it's 18. So then it is between option 1 and 2. Okay, 16 divided by 2 is 8, and that would be 18. Okay, which is then option 1. What they've done here is if you set 16, so the square root of 16 is 4. But if you have it to the power of like that, you basically divide by 2. You don't take the square root of 16. So you basically say 16 divided by 2 and not the square root of 16. So when it's an exponent, you basically divide with whatever is in this, what do you call that, nearly in that triangle thingy. You don't take the square root of 16 because then you would have gotten to the 4 and the 6, which is not right. Okay, so when we look at exponents, it is divided by 2 and not the square root of 16. It is 16 divided by 2. Okay, so that is one of the things that I picked up for you guys to look at expressions. But yes, another 2. So now they've combined it a bit. So what they've done is there's 1, there's 2, there's a minus. In the second one, there's a divide by, then there's a multiplication. So they used some of the expressions that we have a mixture of numbers and variables and exponents. And then we have nearly a mixture of where in the process we need to complete it. Okay, so the first thing, if I get something like this, I will multiply it out. Okay, so I want to get rid of a bracket. It's not that whatever is in the bracket is the same, that we can nearly look at some other algebra that we isolate the bracket. So that's not going to work for us in this instance. So we will need to multiply out. So how we normally multiply out with brackets is we will need to say the 2y to the power of 2. I'm first going to multiply it with x. Then I'm going to multiply that 2y to the power of 2 with the next term. So it is minus 2y to the power of 2. Then to make this for now a bit easier, I'm going to leave the negative outside. I'll do that with the next step. And first multiply in. So I will 8x times y to the power of 2 is 8x y to the power of 2. So I'll do the negative now, and then the 8x times 1 is plus 8x. So then the next step, we can order some of these differently as well. So let's order it to according to the x's first. So that is the same as 2xy to the power of 2 minus 2y to the power of 2. Here, negative 8xy to the power of 2. And that multiply in negative 8x. Okay, so again, we have not simplified it yet, but if I look at all these terms, minus 8 is standing out. So minus 8, plus 8, minus x. So already I would have eliminated 2 of them. So then now let's simplify. So minus, or sorry, 2xy to the power of 2 minus 8xy to the power of 2 is minus 6xy to the power of 2. So that we've covered. That we've covered. Minus 2y to the power of 2. That we've covered. Minus 8x. Okay, so let's see. Minus 6xy2 minus that. So option 2 is the right option. Let's just quickly see what happened in option 1. Okay, so that was fine. That was fine. Okay, so here, that one was fine. You can see it's exactly the same, but here they mixed it up. So if you made the mistake in saying that first one is x, 2y x to the power of 2, that is, so that is where they mixed it up for you, is in that first one that you multiplied out. Okay, so that is where they wanted to catch you out. Okay. So again, when you do this in, especially in your assignments where sometimes there's more time, nearly do the process of making sure that you get your order right. That, and then, like you see how I like to do it, is nearly to identify one of them that's nearly, okay, that's the easy one to identify in your formula. Okay, so what you could have done, Daneo, is what I did is I took that out first and not use the minus. But what you could have done from the start is to say minus 8x times y to the power of 2 is minus 8x y to the power of 2, and minus 8x times 1 is minus 8x. Okay, so that you could have done nearly to skip the process that I've done here. Sometimes the problem is that you use the minus for the first term, and then you forget to use the minus for the second term. So that's why I normally like to keep it still in brackets, because I know I've got the tendency to multiply the minus 8x with the first term, and I forget a lot to then my second term also multiplied with the minus 8x. So that is just, again, you could have done that step as one, but again, just for me, I make less of errors if I first wait with the minus, because sometimes one forgets to multiply the minus with a second term as well. Okay, does that answer your question? So that is just, that second step was just nearly added. Awesome. Okay, last step where we simplified. So let's go from that step, and let's quickly. So again, if you look at what we have here, what I will normally look at is, and let's quickly use a different color. I would look at the things that I know is the simple one. So minus 8x, there's nothing that looks at all similar to that. There's not a x and a y, there's not a x and a y, and the minus 2y to the power of 2 is also one of those that it stands on its own. Okay, so then one looks at those two and see, okay, the x is exactly the same, the y's, y to the power of 2, y to the power of 2, exactly the same. So that answer will be something x, y to the power of 2. And when it is, okay, 2 minus 8 is minus 6. So that is how I got to that last step. So again, I would look at it and look at the ones that's, again, the simpler ones to identify. And then you nearly tackle that combination of x's and y's, and nearly the last step is nearly to look at that one, because that is normally the more difficult one to identify and simplify. Yes, that is also perfect. The minus 8x times a plus 1 is minus 8x. So yeah, that is how it, minus times positive remains a minus, minus times a minus becomes a positive. Okay, let's look now at the last question. We might even start with some of the next chapter as well, but so let's work from left to right. So the first one is, okay, let's say 2. So we're going to start with that one divided by AB. So let's first do that bracket before we even do the division. So we do the bracket first. So then we see that answer is 9, a to the power of 2, b to the power of 4, c to the power of 6. Okay, so that is the first step. Then divide by AB. So where is that one? Sure, going back, divide by something. So we can actually say that is actually A minus 1, B minus 1. And that we can then multiply by 2A3, B4. Okay, so then the first thing I would multiply the 9 and the 2, which gives me 18. So now already there's one option, there's one option. Option 1, option 3 can't be. Okay, so just not even looking at the rest yet, I identified already 2 that you can eliminate. And when it is, okay, A2 minus 1 is A1, plus 3 is A to the power of 4. Okay, A4 can't yet decide. B4 minus 1, so it's B3. B3 plus B4 is B7. B4, B7. Okay, so that one is wrong. And then we've got C to the power of 6. There is not another C, so that is then the final one. 18A to the power of 4, B7, C6, which is option 4. Okay, so again, one can nearly, as you go through the process, eliminate a few of options. I will repeat, don't worry. So I am going to erase this so that I have space again, and we will repeat. Okay, so, and by repeating, I will show you another way of doing it so that you can see all the steps as well. So again, remember nearly BODMAS, we need to do the brackets first with the exponent. It might be easier to do the multiplication first, but I now want to show you another way that it doesn't really matter which one you do first. So I'm quickly going to show you another way that it doesn't matter if you do the division first or second. Normally, yes, it's easier to do multiplication first and then the division, because it nearly gives you more structure. But I'm quickly going to show you another way to do it. So nothing will change with a bracket. So that we always need to do first. So so it's for 9AB and C, so that. So just quickly, where they got to this C to the power of 5 is if you set the C3 plus the 2. So if you set 3 plus 2, you would have gotten to the 5 instead of saying the 3 times the 2. Okay, so that is nearly, if you set, okay, that bracket is, we actually just say 3 plus 2. That is how we would have gotten to the 5 instead of the real value that is 6. Okay, so that is that first bracket. So with division, you can nearly already write that as a -1 and a -1 for the B. So if there was A to the power of 2, B to the power of 2, you could have rewritten it as -2 and a -2. And then what I will just do, take the 2 to the front and then write the rest with it. So then you can also write it to make it is, let's first do all the A's. So that's for 1A, that's for other A, that's for other A. So 2 minus 1 plus 3. So that is all the A's covered. Let's look at the B's. There's the B, there's a B, and there's a B. So it is B 4 minus 1 plus 4 again. And then let's look at all the C's, so C6. Okay, where did I get the -1? So look at, so if you look at this rule, so if we divide by something, it becomes negative. So if we had, so all that we did is by dividing by AB, so we said divide by AB, we said it becomes negative. Okay, so, that must not be there. Sorry, I will erase that. So by dividing by AB, see it also as there's a A1. So if we divide by a to the power of 1, b to the power of 1, it becomes a to the power of -1, b to the power of -1. Okay, so that's where we get the -1. We could have gone another route. So let's first work this out again. So you will see then if you add those together, it will be A4, B7, C6. So another route could have been, let's just at that stage, so we multiplied that in A2, B4, C6 was to say, okay, but let's divide by AB. Okay, so we divide by AB. So if we divide by AB, again, there's another rule. So the rules are nearly, there's some rules that you can use interchangeably. So if you look at, where was it? If you divide and then you bring it up to the top, so there's always the 1. So remember, there's always the 1s. So whenever you bring that component to the top, it becomes a negative again. So that will, let me quickly rewrite that. So if you bring that to the top, it will become A -1, B -1, which we basically here already did, but that is again a way that you can do it. Another way is if you don't get the -1 thing, I'll get to the, how do we get to the 80 now? So if it was again just the AB at the bottom, remember, if let's say here was a 3, we would have said 3 goes into 3 once, 3 goes into 9 3 times. So the same, if there's a 1 at the bottom, we can bring it to the top to say 2 -1, B -1. Okay, so there's a few ways nearly that you can work with that division part. Yes, the 18, it was that 9, the 3 to the power of 2, the 3 to the power of 2 times that 2. So it would have been 9 times 2, which would have given you the 18. Yeah, so Jamie, that was exactly, so it was 3 to the power of 2 which gives you 9 times 2. So what they can also do with this one is maybe add an exponent to it as well to make it more difficult. So that you needed to multiply the 2 with an exponent as well. But I think this is really already difficult enough. So what they basically did here is brackets with a division, then with a multiplication. So a question like question 13 is the most difficult that you guys will get in the assignments or in the exam when it comes to this, and you need to simplify. So that is nearly the most difficult that you will get to. Okay, so let me just, there's a few links that I just want to post again for everyone to nearly get. So the one is an evaluation form for the session tonight. Then the second one that I'm gonna post is the attendance register. And then the last one that I'm going to add is the WhatsApp group. Okay, the 9 you basically get from the 3 to the power of 2. Okay, so the 9 you will get from that original 3 to the power of 2 will give you the original 9. Okay, so that will give you that 9. That 2 was just from that one, so that is why the 2 times the 9. Okay, and then just the last link, if you have not, if you're still not part of a WhatsApp group and you want to be part of a WhatsApp group, you can, on the last link. Okay, sessions every week from 5:30 to 7:30, so we're ending a bit earlier tonight, but from 5:30 to 7:30, except public holidays, but I don't think there is public holidays for you. So let me quickly see. So yeah, there's no no public holidays. I think, yes, there is one next Thursday, but we will have class on a Wednesday. So 20th, 27th, 3rd, 10th. So you can see there is nearly for every, there might be the 1st of May might be a public holiday, and which we might not then have class, but all the other days we will have. We'll work through all of the chapters, and then we do exam prep until you write exam. We don't know the date yet. One-on-one session, send an email to my UNISA email address, so that we can book a one-on-one. So one-on-one, send to my UNISA email address. I will organize a time that suits you. Then I'll set up as this a team session. I normally will copy in one of the guys from UNISA that they can just see that we are having it, so that they can just also on their side take record. But yeah, so if there is anything that you struggle with, that there's a topic that you want a one-on-one session with me, we can organize that. So we'll squeeze that in between all the other sessions. It might also be that we do a one-on-one, but it might be that it's 2 or 3 people that sit with the same problem. Then it might be just a smaller mini group that we do. So you can just email me and we can see where to fit it in. No problem at all. So I'll check in with, so let me stop the recording so that we can quickly